Hello. Today I explain how rockets are used to change the velocity of spacecraft. Newton's third law states that for every action, there is an equal and opposite reaction. This is why you feel recoil when firing a rifle. The bullet is expelled in one direction, while the gun recoils in the opposite direction. The recoil is larger for bullets with larger mass and faster exit. For spacecraft, we expel gases rather than bullets, but the concept is the same. Rockets are used to expel gas. The resulting change in spacecraft velocity is given by the following three equations that are equivalent. In these equations, the letter V preceded by the Greek delta symbol is the change in velocity called delta V. A is the acceleration, Ft is the rocket's force or thrust, ms is the mass of the spacecraft, and T preceded by the delta symbol is the time duration of the rocket's thrust. When the rocket burns are short and produce small changes in spacecraft mass, we can use the first equation as a good approximation, assuming that we know the required delta V. However, for other burns, especially those that occur over longer times, we must use the last equation. In these situations, the direction of thrust can change over time, and the mass of the gas expelled can be large. In our simulator, SOS, you can specify rocket burns either way, as a single delta V with magnitude and direction, or as acceleration with magnitude and direction, plus time duration. For example, you can specify a delta V of 100 meters per second, or acceleration equal to 10 meters per second squared, and time duration equal to 10 seconds. You can experiment with these two methods. You'll see that as the rocket burn duration gets shorter, the difference in the results will become insignificant. Another good reason for using the equation that requires delta V is that the rocket equation gives delta V. I show this equation now. Remember that in this equation, MSI is the initial spacecraft mass, MSF is the final spacecraft mass, and VEX is the rocket exhaust gas velocity. This equation is derived using Newton's third law, or conservation of linear momentum. Thank you for watching this video. If you find it useful, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We also need your feedback, so please leave comments. Goodbye.